Part 2. In this part, we will be studying how to solve the problem formulated in Part 1 using graphs. Graphical method can only be used in case of a two-variable problem, that is, in form of x and y or a and b. If there are more than two variables, graphs cannot be used to find the solution to that LPP. Now the question is that how do we use graphs? Let's pick up the same problems we formed in part 1 but with x and y only. So now the objective function becomes that we need to maximize z, which is equal to 4x plus 5y with respect to constraints which are 0.5x plus 0.4y is less than equal to 100 and 0.25x plus 0.3y is less than equal to 100. Also, x and y are more than equal to 0. Now let's plot both the equations on a graph considering they are normal equations with equality symbols. So the values of x and y are as follows. The values come out to be that when x is 0, y is equal to 250 and when y is 0, x is equal to 200. So the line representing equation 1 will pass through the coordinates that is 0 250 and 200 0. Similarly, for the second equation, the values of x and y come out to be that x is 0 and y is 333.33, while when x is 400, y is 0. So, in a similar way, we can plot these points also. With both the lines plotted, our graph looks like this. Now we shall consider the inequalities. We shall shade the portions that are represented by the inequality equations here. Say we check for the point 0 0. So basically what we need to do is that we need to put the values of x and y as 0 0 respectively in both the inequality equations and then verify if the inequalities stand true or false. So if the inequalities stand true, then we need to shade in the direction of the coordinate chosen by us, that is 0 0, and if the inequality stands false, then we need to shade in the direction opposite to the coordinate chosen by us, 0 0. Similarly, 0 0 satisfies equation 2 as well, so we highlight the following area. So now after shading both the areas, our graph appears somewhat like this. But since we know that x and y both are more than or equal to 0, we should not consider the area left to y-axis and below x-axis. So our shaded area remains contained to intersections at point 0 0, 0 250 and 200 0, the common area which satisfies all the constraints. So our solution shall be one of these coordinates for which we shall check the profits at each coordinate. The profit is checked by putting the values of x and y at these coordinates in the objective function. Since the profit is maximum at the coordinates 0 to 50, our solution is that x is equal to 0 and y is equal to 250. And at such a point, our profit is rupees 1250. So part 2 ends here and it's time to pick up the practice manuals again.